Okay, friends, one last little video here to kind of wrap up what we've been talking about and also kind of take a peek forward in the world of statistics. So statistics has a couple different branches, one of which we're going to get right into beginning in next week. The other one we're not going to see till about halfway through the course. The first branch is called descriptive statistics. Descriptive. And what that means, it's not a very good name, honestly, but what it means is you are studying something, whether it's a small sample from a larger population, we'll come back to that in a second, or whether it's an entire population, if the population itself is small enough to study. And then you report back on that, and that's where you stop. For example, years ago, I remember helping a buddy of mine who was in recruitment here at COCC. She had gone out to a number of different schools and used a number of different methods to kind of incite interest in COCC. And she tracked in each of the different methods what percent of students got back to her. And she told me, oh, Sean, don't you think this is interesting? Method A, they responded 30% of the time. Method B, 40% of the time. But method D, 80% of the time. Those are cool. Those are descriptive statistics. Because she did a study where she collected data and then reported back on them. Descriptive stats. You ever look at the back of a baseball card? Those are descriptive statistics. That's how a player performed over a given number of seasons. If you read the financials in the newspaper or online, if you ever look at financials, kind of stuff like that, those are descriptive. That happened. It's stuff that happened, and it's simply a report of stuff that happened. Awesome. Here's another example of a report of something that happened. Years ago, I used to play in a band called Hands on Throat, and on the way to practice, I would often stop by Del Taco and get some half-pound bean and cheese burritos to fuel my practice. That's before I looked at the ingredient list. We'll come back and talk about that later in the course. Anyway, I got to thinking on one particular bike ride down to practice, why are they called half-pound bean and cheese burritos? I better check that. So I borrowed a really precise scale from the science department here at COCC, and I took a sample of 30 half-pound bean and cheese burritos. Here are the weights I got. And I took the average of them, ended up with a number, and we're going to talk about those later in the course. If I stopped there, that's descriptive statistics. I took a sample. I then did something with the sample, in this case took an average weight, and then reported on it. But suppose I wanted to go further. Suppose I wanted to say, that average is not what I was expecting. I wonder if the average in the entire population is different significantly than the average in my sample, or vice versa, if the average in my sample is significantly different than the average in the population. Now, I just used a couple words there. Sample, population. Generally speaking, a sample is what you're able to get in statistics, because populations, generally speaking, are too big to gather completely. There's only one population measure that I've ever seen with any kind of frequency in this country, and that's called the census, which is in the U.S. Constitution. It has to happen every 10 years. A census is a measure of an entire population. Generally speaking, you can't get that. So what you settle for, instead of a census of a population, you take a sample of the population. Okay. Now, you have an entire project about how to do that properly. That's not due till, I think, week 3. So I'm going to let the project explore that deeply with you. But assuming you do good sampling, or minimize the bad sampling, you're going to get a number from that sample. Now, let's go back to the population for just a second. You are interested in a population, generally speaking. And that population has a measure. It's called a parameter. So, for example, going back to the Del Taco half-pound bean and cheese burrito example. That half-pound bean and cheese burrito average weight is out there in the population. I'm never going to know what it is because there are too many half-pound bean and cheese burritos to actually measure. But it's out there. So I can't get it because it's a parameter. It's a measure of a population. What can I get? Well, I can get my sample measure. What's a sample measure called? A sample measure is called a statistic. And that's why the course is called Statistics and not Parameters. If the class was called Parameters, this would be the easiest class ever. You would come in on the first day and I was like, okay, welcome to Parameters 101. Your homework is to go out and count every single person in a population. Cool, I'll see you in week 10. And by the way, you're gonna fail because you can't do it. It's just ridiculous. I mean, think about how much trouble the Census Bureau has trying to count everybody, and they've got a governmental wing dedicated to them. As researchers, as consumers of statistical information, you're not going to have access to entire populations in general. Sometimes you have very small populations like my class. I can look at you, call you my class as my population. I can study you all day long. But if I'm interested in, say, an average COCC student, I generally won't be able to talk to every single one of them. Now, there's only one of me and there's 6,000 of y'all right now. So generally speaking, I'm interested in a population. And in particular, I'm interested in a parameter, which is the measure of a population. But what I'm able to get is a sample from the population. And within that sample, I can pull a statistic. And the back part of this course is dealing with the connection between a sample and its statistic and the population and its parameter. That branch of statistics that puts those two things together is called inferential statistics, because we're trying to infer something from a sample about a population. So we're going to start with descriptive stats and move ourselves to inferential stats later in the course, but we'll dial the descriptive stats in starting in week 2. Okay, I think you have enough to give the homework a shot. Go get them.